You ever stop and think about what's really happening inside that box on your desk? Well, today, we're going to pull back the curtain and demystify the magic that's happening literally every single second. We're going to trace the path of something super simple, an action you probably do thousands of times a day, just pressing a key.
I mean, it seems completely instant, right? You press a key, the letter appears. But what feels like magic is actually this lightning-fast trip through all the core parts of your machine. It's pretty wild. Okay, let's dive in and see how it works.
You know, at its heart, you can really boil this whole complicated thing down to just 3 simple steps. First, there's input. That's you telling the computer what to do. Then, there's process. That's the computer, doing its thinking. And finally, output, where it shows you the result.
All right, so let's start at the very beginning. How do we even talk to the computer in the first place? Well, this is the input phase. This is where it all kicks off.
So, what's an input device? Well, think of it like a bridge. It's basically anything you use to send information and instructions into the computer's brain. And the thing is, we use these bridges constantly, probably without even thinking about it. Your keyboard, your mouse, even the microphone you use for a voice command. Or hey, a scanner that turns a piece of paper into a digital file. These are all just different ways we give commands and get this whole process started.
Okay, now for the magic. Once your command is in, where does it go? It goes straight to the heart of the whole operation, the central processing unit, or as you probably know it, the CPU. This is where the real process part of our journey happens.
Yeah, people call it the brain of the computer all the time, and honestly, it's a perfect analogy. Just like our own brain, the CPU is the total control setter. It's not just doing the work, it's the boss, directing and managing every other part in your system.
So, here's what's really interesting. This brain, it's not just one big blob. It's actually made up of a few different super specialized parts, and each one has a very specific, very crucial job to do. So, let's break them down.
Okay, first up, we've got the control unit, or CU. The best way to think about this guy is like a project manager, or maybe a foreman on a construction site. It doesn't do the heavy lifting itself. Nope. Instead, it reads your command and then tells all the other parts what to do and exactly when to do it.
Then, you've got the Arithmetic Logic Unit, or ALU. This thing is the master calculator. It's the part that handles all the math, adding, subtracting, and all the logical stuff, like figuring out if one thing is bigger than another. It is the absolute number-crunching powerhouse of the whole operation.
Okay, so we've got the foreman, the control unit, giving out orders, and we've got the calculator, the ALU, ready to get to work. But to do all this, they need space, right? They need a place for their current projects, and they need a different place to store stuff long-term. And this brings us to a really, really important distinction. And this is such a great way to think about it. Imagine RAM, that's your memory, as your workbench. It's where you lay out all the tools and all the parts for the project you're working on right now. Storage, on the other hand, like your hard drive or SSD, that's your filing cabinet. It's where you keep everything you own, even the stuff you're not using at the moment. But here is the absolute key difference. RAM is volatile. What does that mean? It means when you turn the power off, your workbench gets wiped completely clean. Poof, gone. Storage, though, is non-volatile, so everything in that filing cabinet stays right where you left it. And that's why having more RAM helps you multitask. It's literally like having a bigger workbench so you can spread out more projects at the same time.
All right, so the command has been processed by the brain. Let's move on to the final step of our journey and see how all this work turns into something we can actually see and understand.
So, after all that super fast calculation inside the CPU, an output device takes that digital result and translates it back into something a human can understand, something we can see or hear or even touch. In short, it's the computer talking back to us.
And hey, just like we have a bunch of ways to talk to a computer, it has a bunch of ways to talk back to us. The most obvious one is, of course, your monitor showing you text and pictures, but it also includes your printer spitting out a physical copy of a document or your speakers playing music.
Okay, let's put all the pieces together now. We're going to trace the full, ridiculously fast journey of that single key press that we started this whole thing with.
So check this out. From your finger to the screen, it's this perfect little dance. First, your keyboard sends the input. The CPU's foreman, that's the control unit, gets the command. It then goes to the filing cabinet, storage, and pulls the data it needs onto the RAM workbench. Then, the calculator, the ALU, does its thing. And finally, the result is sent as output to your monitor, and boom, the letter H appears on your screen. All of it just instantly. And here's the part that just blows my mind: the speed. This whole trip from input through every part of the CPU's brain and out to the screen happens in a tiny, tiny fraction of a second. And remember, this isn't just happening once, it's happening constantly for every single thing your computer is doing right now.
So the next time you press a key, just for a second, think about that incredible, high-speed journey you just started inside your machine. It really makes you wonder, doesn't it? As this whole process gets even faster, even more complex, what comes next? What's even possible when this journey happens not just millions, but billions of times, every single second?